Welcome back, everyone. So now that we know what mass and volume are, how does that relate to density at all? Well, density describes a measurable quantity relating to how much stuff or mass is in an object and how much space or volume that object occupies.
And we know that from the first video.
Yeah, exactly. So density describes the relationship between the mass and the volume of an object. So, based on these two pictures, which one do you think has a higher density?
Hmm. Well, you mentioned how crowded stuff could be correlated to mass. And so if I was putting up my toys, when there's nothing in my toy box, I would probably say that's low density for that box. But when I put up all my toys, they're really crowded in that box. And the boxes look about the same volume. So I would have to say the image on the right with all the toys has a higher density.
You're exactly right. Both boxes are the same size or take up the same space, so they have the same volume, but one box has more stuff or more mass in it than the other one. So the one with more stuff in it has a higher density.
And wow, I it's interesting that you can relate my toy boxes to those images, the cubes with the green objects inside them. I see how that might relate to other objects in life.
Yeah. So once again, he made that perfect distinction. That box on the left with less stuff in it has a lower density. So, like we said before, the object on the right has more stuff or mass in it, while it takes up the same amount of volume. So you can think of it as the object on the right is more crowded. And the more crowded something is, the higher the density is.
That makes sense.
So let's do another example. Which group of people is more dense or has a higher density?
Wow, I really like those superheroes. That was a really good movie. Um, I'm back to the more crowded point. I think the picture on the left is much more crowded. I mean, they don't have any personal space. So I would say the object on the left has a higher density.
And that's exactly right. So you can also think of it as which group of people is more crowded. And that's the one on the left. So the one on the left has a higher density. So which ball in this picture has a higher density? And why is that so?
This one's a hard one. I guess the ball still contains some same amount of stuff. So I would say the mass is the same. But one object, the same object when it's squeezed, I would say it takes up less space. So maybe the object on the left has a higher density because it has less volume. So the stuff in the ball is actually more crowded.
And that's exactly right. So like he said, the object on the left takes up less volume or less space, and it still has the same amount of stuff because that ball is the same ball as the picture on the right, so it still weighs the same, but the one on the right is less crowded. So let's do one more example. Which pool has a higher density of people in it? The smaller pool on the left or the larger pool on the right?
Hmm. Well, both pools have two people in them, and those are the same two people. So I would say the stuff that's in the pool is the same. But the pool on the right is a lot larger. So it has a lot more water in it. So it must have a bigger volume. So the pool on the left is probably the one that's more crowded. So I'd say the pool on the left has a higher density.
That's exactly right. The pool on the left has a higher density. So now that we know what mass, volume, and density are, we can start to think about that sink or float experiment and why certain items floated and others sank. So,
I guess when the objects had a density higher than water, so they were more crowded, they must have sunk. So, like heavy objects, like for example, a 10-pound weight, they would sink in water. But the objects that had a lower density, like a rubber duck or the chess piece or the game piece, they floated because they were less crowded in the water.
yeah, exactly. So when you thought of a heavy item or an item that had a lot of mass, like the candle, it sunk because it was very heavy and it didn't take up that much space.
That
But
makes
then
sense.
on the opposite end, there was a piece of cardboard. And that piece of cardboard takes up a lot of space, but it doesn't weigh very much. So it floated.
Wow.
So in the next video, we'll look at how this relates to chemical engineers or mechanical engineers. And the great part is you get to decide whose shoes you want to step in, a chemical engineer or a mechanical engineer.
They'll be so fun.